So what I thought I would do is first just educate you a little bit about sleep and what we know about the idea of circadian rhythms, how we measure sleep, and then what the consequences of sleep deprivation are. My work is specifically looking at how obesity and sleep are linked and how having too little sleep is actually linked to greater risk of obesity. And then I'll talk a little bit about sleep hygiene and what you can do if you're not getting enough sleep. And I'll be sure to sprinkle in some of these extra things. So any kind of time we talk about a circadian rhythm, this is what you got at was the idea of the waves. Those happen in 24-hour cycles, and for the most part, they are controlled by light and dark cycles. And this can refer to any kind of rhythm that you have that occurs for biology, physiology, your mood, even your performance can all be linked to light and dark cycles. And we know that these light and dark cycles are in part controlled by what we consider to be the clock in your brain or the suprachiasmatic nucleus. And what's important to realize is that you actually have a cycle in your body that runs at about 24 to about 25 hours. And there's been some really nice work that's done to look at this and the idea of looking at a free running cycle. So if I didn't expose you to any light cues and let you get up and go to bed whenever you liked, you actually would have this idea of a free running cycle, that every night you'd actually go to bed a little bit later, so the black bar indicates your sleep, and if you can imagine this being a 24-hour clock. So every night you'd go to bed a little bit later, and you'd actually get up a little bit earlier, and that would happen over time. Now what we actually have is that be if I could put you either in constant darkness or in constant light. It works better in constant darkness. If, on the other hand, I keep you to a 24-hour clock and I purposely have a light and a dark cycle, I can actually quickly have you zone in on. You'll actually quite regularly maintain your circadian rhythm. And the idea is because the light is giving your brain a cue. And so the light actually operates through what we call the retinohypothalamic pathway. And it's the idea that you actually have special little sensors in the back of your eyeballs that are sensitive to the light, that are specifically feeding in right to this brain clock, your suprachiasmatic nucleus, and sort of keeping you on schedule. And that sort of helps you maintain when you wake up and when you go to sleep. And what we refer to as any of these cues that reset your cycle as Zeitgebers. And Zeitgebers can be anything. For a while, we used to think that it was melatonin that was a big Zeitgeber, and that's a hormone that's produced in your brain that would help reset your clock. And we've actually come to realize that light is a far more powerful Zeitgeber than any other kind of hormone. And so light, like light and dark, actually helps reset this clock and helps you maintain and stay consistent with the 24-hour cycle. And that will be important at the end of my talk when we think about sleep hygiene and why you might be getting out of sync or out of phase. I can also relate this to two things that I'm sure you've heard of, jet lag and shift work. So people that are jet lag actually have the idea of they can be phase delayed or phase advanced. And phase delayed means that they actually are able to get up later and later, so the phase is a delay. And phase advanced means basically it's all happening too soon, so they're actually getting up too early and they're going to bed too early. And you can have this, and if you ever notice if you traveled to a different time zone, that traveling west is always easier than traveling east, because when you travel west, you're actually able to sleep in later, and you can go to bed later to accommodate that cycle, and then when you come back east, you have a harder time adjusting. People that are doing shift work, if they can maintain a very bright environment, almost as bright as it would be during a noonday, they actually can minimize a lot of risk, a lot of injuries and accidents that would occur during shift work. And they've actually found that if you can rotate individuals' shift work, that if you rotate them forward, meaning that you keep allowing them basically to keep going to bed later and getting up, or going to bed later, getting up later, that actually is a more accommodating way of shift work than if you try to make them work backwards and get up earlier. So a lot of this information has informed what we know about sort of just general normal functioning. So let's pause and think about how we actually measure sleep, because there are a few different ways that we can measure sleep, and it will be important for some of the things that I'll tell you about later. So at the most simple level, we can do a self-report. And so a self-report is often done by the individual themselves, but when individuals are younger, say I often work with children, we would have the parent fill out a sleep diary. But we also can have roommates, partners, and spouses fill out a sleep diary as well, because you might not be the best indicator of how well you're going to sleep or how well you're waking up. And it's not uncommon that we would have both the individual and their partner fill out sleep ratings so we can have a sense of what might be going on. And so there are different ways we can use a sleep diary. In this sleep diary here, an individual will be writing in the day or the date, and they would just mark on the grid here what time they went to bed. And then they would ask them to try to indicate how long it took them to fall asleep. And we look at that gap as what's called your sleep latency. So the amount of time you spend in bed before you actually fall asleep is the latency. And what we want you to do is have your sleep be as efficient as possible, so the time spent actually in the bed is time spent sleeping. So a person would sort of fill this graph out. We can also have them fill out different types of rating scales, so indicating about how sleepy they are, what their quality of sleep like, if they're sleepy during the day, if they found that they woke up a lot, if they felt that they were really fidgety, if they thought they were snoring. So all of these things can contribute to your sleep quality. A slightly more advanced way of measuring sleep is doing actigraphy, and you actually have something like this. It looks like a little watch that individuals would wear. And this watch measures your sleep and your wake patterns, and it essentially measures movement. So just like we give people pedometers to wear around to help them measure how often they're exercising or doing a lot of different physical activity, we can have them wear an actigraphy watch that they would wear to sleep at night, and this would give us an indicator of how much they're restless at night, and if there's periods of non-movement. So it's a pretty good indicator of sleep, and we often use this in conjunction with sleep diaries. The most gold standard, or the supreme way of measuring sleep, is through polysomnography, which is PSG. And so when we do PSG studies, we actually have a number of electrodes that are going on the individual to measure different physiological signals. So basically, there are three major things that we want to capture when we're doing a PSG study. And so PSG is going to measure EEG, so looking at different brain waves, so an electroencephalogram. We have an EOG, so that's looking at eye movement, so you have electrodes actually placed near the eyes. And then lastly, we have an EMG, so looking at muscular movement. And so all three of these things together form the PSG, or the polysomnograph. And so this really is what it could look like if you were to go in for a PSG study. And it usually takes about an hour to an hour and a half, maybe upwards of 2 hours, to put all of the different electrodes in place before the individual goes to sleep, right? So we have them do all of this, and we often have them go into a special sleep clinic and put all the electrodes on. But there are some refinements of this that are starting to happen nicely with a lot of technological advancements, that we can have people wear an ambulatory monitor with just a few of these electrodes, and they can actually go home in their own bed and sleep. And believe it or not, I actually get kids now to do this, and it works out wonderfully. So what's the information that we get from a PSG? Basically, like I said before, we get the information on your brain activity, your eye activity, and muscle activity. Let's see if I can use this. So we can look at the EEG activity, the brainwave activity, and based on the types of patterns and the data that we're getting, we know what stage of sleep individuals are in. Go like this. So these would be considered to be awake activity, and this is a lot of alpha waves that are happening here. You then have stage 1 activity, and you start to see a little bit more synchronization here. Then for stage 2, we have what's known as sleep spindles, and you can also get what's known as K complexes, and you can get some K complexes in stage 1. This would be an example here, and they actually start to look like the letter K. That's how they got their name. Then you have stage 3, where you have a lot more synchronization of your EEG activity. Stage 4, again, we start to have these delta waves. And then finally, you have REM activity. And interestingly, REM activity used to be considered deep sleep. We don't really call it deep sleep too much anymore. But what's interesting is you are fast asleep, but your brain is producing electrical activity that looks almost parallel to what we see when an individual is awake. And so this is often why REM sleep is known as paradoxical sleep, because it's really quite odd that here you are fast asleep, but your brain is functioning as though it's wide awake. And so these stages of sleep are together how we best understand what's going on while you're sleeping, and we can look at the pattern of your different sleep activity. So what I have here is a diagram. I'll sort of just break it down a little bit. So you actually cycle in and out of REM activity over the course of the night. And I'll show you another picture of this in just a second. But the key thing to realize here is that when you see a red bar, you're in REM activity. That's rapid eye movement, or the paradoxical sleep. And so these are just to show you some of the differences that are occurring when you're in different stages of sleep and the outcomes they have on different parts of your body or different body processes. So we see lots more eye activity when we are in REM sleep, and that's based on the EOG, so the little electrodes we put on. That really is only occurring during the REM sleep. Your blood pressure is actually higher when you're in REM activity. Here you have the number of breaths that someone is taking, and so you're breathing far more rapidly during REM sleep. Your heart rate is also beating much more fast and much more erratic during REM sleep. And then lastly, you actually have very little body movement here when you're in REM sleep. So it's these things together that are producing the different patterns that we look at to try to understand what's happening in your body. So again, if we look at the stage sleep scoring, we're specifically thinking how you're coming in and out of REM activity. And we can look at that also in this idea of a hypnogram. And a hypnogram shows that over the course of an evening, you're actually spending more and more of your time in REM sleep. And this is important, partly what you were getting at. Well, what if people are only limited to 4 hours? What you see is your body, if we actually, I don't have a picture of it, but if you actually have individuals that are sleep deprived, their sleep starts to look more and more like this, that they're desperately trying to get REM sleep, and the high majority of the time is spent in REM sleep because their body is sleep deprived, and specifically REM sleep deprived, and you need REM sleep. So here's an example of some of the different things you see in REM versus non-REM sleep. So again, the EEG pattern, so the brainwave activities look very similar and quite different during non-REM, far more synchronized. For the EOG activity, that's your eye movement, it's quite different during non-REM and REM. And then during EMG activity, again, this is your regular movement. You have very little movement during REM sleep. That's that idea of that paradoxical effect compared to when you're awake. But in non-REM sleep, you are in fact, again, moving around. So how do we know that REM sleep is important? Well, a while back, there were some crazy scientists that had some pretty interesting and mean ideas to learn about why we really needed REM sleep. And so what they did is they did a lot of work depriving animals of sleep to see what the effects were. And they found that you could actually sleep deprive an animal quite well and they would adapt, meaning they would find other periods of time during the day to sleep. So then they started learning more about the electrical activity that was occurring, and they identified these different sleep stages. And so they wanted to know how important it was to have REM sleep. And so what they actually were able to do is put like a cap on the rats or the mice, and they can actually figure out when they're going into REM sleep based on the EEG activity. And they developed this over-the-water disc apparatus. And what they would do is basically, anytime the rats fell asleep, the disc would stay stable. But as soon as the rats started going into REM sleep, they would tip the disc so that the animals would fall into the water. So the disc was actually suspended above water, hence they would wake up. So therefore, they prevented the rats from going into REM sleep. And they didn't have to do very many of these experiments because the animals all died within a few days. So you really can't be REM sleep deprived because the imminent consequence is death. And it doesn't take that long. There are some researchers that actually believe that you actually can't go as long without REM sleep as you could go without food. So it's really, really quite critical to have REM sleep. So this is one of the first studies that was done to really demonstrate the importance of REM sleep. Since that time, we've learned a lot more about sleep deprivation in humans, and we know that it's more than simply a restorative process. It's responsible for a number of different physiological events, and specifically one major role that's gotten a lot of research and a lot of attention is through memory consolidation. So you can think about eventually how this is going to play out to college students, because without a lot of good sleep and with sleep deprivation or even sleep restriction, you see a lot of problems with performance, academic performance, and this is related to memory consolidation. So the worst thing students can do is actually cram and not sleep very much during their study periods, because that actually is not helping them remember all the stuff they're trying to cram. So after we did the experiments with the animals to demonstrate what would happen if we completely eliminated their REM sleep, there have been experiments that have now looked at sleep deprivation in adults and also what we think of as sleep restriction. Because truth of the matter is, for the most part, most people don't go a lot of nights in a row without any sleep at all. Instead, what we have happen is people go a lot of nights in a row with sleep restriction. They're limiting the amount of sleep that they're getting. And so there's a great researcher, Yvonne Cotter, out of Chicago, that has done a lot of really interesting work looking at sleep restriction in humans. And so what she found was that if you look at a number of biological processes that are occurring, comparing individuals that get 4 hours of sleep in a night versus 12 hours of sleep in a night, you really see dramatic changes in their physiology, and this only takes a few nights to accomplish. So what she had done is asked these individuals, they were restricted to 4 hours in bed of night for 6 nights in a row versus 12 hours of sleep in a bed. And so when you were given 4 hours of sleep, on average, people were sleeping for about 3 hours and 50 minutes. When you were given 12 hours of bed, they were actually only sleeping for 9 hours. So she looked at a few different things. So she looked at leptin. Leptin is basically associated with your appetite. It's an appetitive hormone. And so we saw big differences in terms of the change that we have for those that are sleeping only 4 hours versus those that are allowed to sleep upwards of 12 hours. And what's interesting is that we know that individuals that are sleep restricted often report much bigger appetites. They're more hungry, and they're hungry for different things. They're hungry for fats and salts. So being sleep deprived impacts your appetitive hormone, this leptin hormone. The other thing that it impacts is your cortisol. And I apologize, I should have told you that this black bar, similar to the circadian graphs that I gave before, black is when they're sleeping. Okay, so this is sort of showing over the course of 24 hours. So the black bar here is also now looking at cortisol. Cortisol is your stress hormone. And so what we find is that individuals that are sleep deprived actually have changes in their cortisol concentrations. That in general, this is sort of what we see as a nice normal diurnal curve. But in general, the cortisol profile as a whole, if we think of what we call area under the curve, is elevated. There's more stress hormone floating around in your body when you are sleep restricted. Interestingly, stress is also linked to risk of obesity. HOMA is an indicator of insulin, or essentially your blood sugars. And so we see some changes, particularly here is the idea of the green region, that you have much higher levels. So your body is craving more sugar in its system. It's probably also to combat like how fatigued and tired and sleepy it is. And then we can also look at what's known as sympathovagal balance. It's a very fancy way to think about how your heart rate fluctuates. And so what we find is that you actually want your heart rate to fluctuate quite rapidly and quite frequently when you are functioning in your daily activity. So the idea, it goes way back to the whole flight or fight response. So when the monkeys are being chased by the jaguar in the forest, you want it under all of a sudden a panic situation where it's being chased and it spots the jaguar to all of a sudden its heart to race and for it to be able to move and get that blood to those vital organs and run. And then when all of a sudden the jaguar isn't around any longer, that the blood and the heart rate calm back down. So you want your heart rate to actually be quite responsive to things that are occurring in your environment. And what we see happens nowadays with humans is that we actually ruminate, we actually think, and that in and of itself can often sustain an elevated heart rate. And so the event has ended, we're no longer being chased by the jaguar, but we're still thinking and ruminating about the exam, and if only I answered that other question, and why didn't I put in number 2 instead of number 3? And that kind of mental reactivation has changes in terms of one's physiology. And so we actually find that people have an elevated heart rate and it's not as responsive to the environment, so that they sustain a higher level of activation in their body systems. So Eve found all of these differences that she actually could experimentally induce by asking people and restricting their sleep to only 4 hours a night versus giving them the opportunity of sleeping 12 hours a night. So this is pretty convincing evidence to start to look at what we call short-term sleep restriction. The question is, we actually do even more than this, right? Because oftentimes when we're restricting our sleep, it's not for 6 nights at a time. It's for months of periods at a time, for years of periods at a time. That's harder work to do experimentally, but I'll talk about ways that we've looked at that and the ways you can look at that experimentally. So some of the things we started to learn about in terms of REM and the need for REM is that there's actually a developmental pattern. That depending on your age, the amount of REM sleep you probably need slightly starts to differ. So in general, when you're younger, the top of this gray bar here is your total amount of sleep time. You need a lot more sleep when you're very young. And that sleep slowly drifts off. And then later on in life, it sort of continues to drift off, but at a much slower slope. The REM sleep that you get, so here's the amount of REM sleep that you have. This is the non-REM sleep. And so you can see that early on in life, your REM sleep is actually quite important and takes up far more of your total amount of sleep. And that changes and actually has I could magnify this, it actually has a much bigger decline later in life. And that's why they believe that individuals, particularly children, that are really deprived of REM early on have been associated with having far more learning problems and developmental delays later in life. And they believe that this may have something to do with it, that the amount of REM sleep that they're getting is important, as I said before, for that memory consolidation, and that may be important for academic learning. But that's early on. So this brings us to the question that you asked of like, well, how much sleep do I really need? And different species have all different sorts of sleep needs, ranging anywhere from 3.8 with the sheep all the way up to the armadillo at 20.4. But if we think about humans, infants, like I said before, need about 16 hours of sleep, toddlers about 12. Teens and young adults, this would be college-age students, need 9.5 hours of sleep every single night. Adults, it could go down to 8 hours of sleep a night. And so I'll talk in a few minutes and tell you about some of the recent sleep surveys that have been done and show you how we're not getting anywhere near that amount. Okay, so what are some of the consequences of sleep loss? We know that people that sleep fewer than 6.5 hours have a number of different problems that are associated with shorter sleep. So in general, if we think about just your overall mortality rate or how long people live, that you actually have a 1.7 times greater risk of mortality. In other words, you have a shortened lifespan if you sleep less than 6.5 hours a night. There's great evidence that you have increased risk for heart disease as well as GI or stomach problems. You also have a greater risk for what we call minor medical illnesses. Your immune system starts to be compromised. You have a greater risk for colds and flus in poor sleepers. And there's some pretty interesting experimental work that's been done with this. They can actually bring in a group of individuals, just like Eve has done, and restrict their sleep, and then expose them to the cold virus. They actually have them like inhale the cold virus, and they look to see who develops a cold and who doesn't. And they find that the people that are sleep deprived are more likely to actually get a cold. You can have greater irritability, depression, and anxiety, and you can actually have greater levels of psychiatric illness and diagnosed depression and anxiety, not just these mood symptoms. There's a lot of interesting work coming out of Cornell University showing that you have a greater risk of automobile accidents. In fact, fatigue trumps alcohol in terms of being associated with alcohol accidents, or I'm sorry, automobile accidents. And the idea is that they believe that fatigue actually impairs your sense of driving far more than alcohol does. And then combined with the fact that most often when you're drinking alcohol, you often are tired, it's late at night. But there's some really interesting work looking at this. You have decreased work performance and memory lapses associated with shorter sleep, marital, social, and employment problems. And I have a colleague that actually is doing some really interesting work looking at marital problems because most of the time you have a bed partner, and so your sleep problems actually affect your partner's sleep problems. Difficulty learning and poor academic performance, and there's the question of whether or not it's experimentally or causally linked to obesity, and that's sort of a current question. And I should make a comment that as much as I'm making a big deal out of sleeping too little, there are problems with sleeping too much. However, when we're thinking about too much, that's when you're sleeping more than 11 or 12 hours a day. So I've sort of talked to you a little bit about circadian rhythms, measuring sleep, and sleep deprivation, and now I'm going to shift gears, and I'm going to talk about obesity and think about how that's linked to sleep. So currently there is an obesity epidemic. It has officially reached epidemic proportions as defined by the World Health Organization. 22 million youth aged 5 and under are considered overweight worldwide, and that's also true in developing countries. Worldwide, 10% of school-age children ages 5 to 17 years are either overweight or obese, and more than likely this is an underestimate based on the most recent data that's coming out. This was as of 2005. The most recent data for Canada suggests 25 to 30% of youth are both overweight or obese, overweight being your 85th percentile above what you'd expect for their age and height. There's also what we think of as a health disparity for those that are of lower socioeconomic status, that people that are poorer have a greater risk for being more obese. So individuals that are overweight, we have 35 to 33% of boys, 33% of girls are overweight compared to at the same time the rate of 10%. And 13% of boys and girls are obese compared to the 10%. And these are individuals that would be considered to be poorer. If we can measure your income in quintiles, people that are at the lowest quintile have the greatest proportion of overweight and obese. This isn't just a problem that exists in childhood or that you're going to grow out of. There's this concept of tracking. And this is the idea that if I take those quintiles and I can identify which quintile you fall in, odds are you're going to remain in that same quintile over time. So as you get older, if you're already in the top 20% of risk, odds are as you are a teenager, you're going to stay in the top 20% of risk, as you're as a young adult, top 20%, and adult, top 20%. So this is the concept of tracking. And so we find that 26 to 41% of obese preschool children and 42 to 63% of obese school-aged children are the people that are becoming the obese adults. So odds are the obesity stays with you as you get older. So this is sort of an interesting thing that here we are, we have this obesity epidemic that over time society is getting bigger, proportions of people are getting bigger, and we also have something happening interestingly with sleep. That in general, the total sleep duration is decreasing. And this is the starting clues of why scientists started thinking, well, wait a minute. At the population level, we have people getting bigger, and we have a population that's spending less and less time sleeping. So now is the idea of we're starting to think about how might these be linked. So if we think about the amount of time people are spending sleeping, it's actually been decreasing over time. And so if we look here, this is just as an example, at age 2 years, in 1974, most 2-year-olds were getting about 14.2 hours of sleep, and in 1986, they were getting about 13.5 hours of sleep. It doesn't sound much, but we find that even just 15 minutes of sleep a night can make a big difference in terms of one's weight. And people were wondering, well, why is this? What's so different about why people are sleeping less now? And people say it's due to a lot of the societal pressures. And what we find is that people probably don't go to bed any differently, or I'm sorry, they go to bed later and later and later, but they're not waking up any differently than they used to. The wake times really haven't remained unchanged all that much, but people are staying up later and later to study for homework, because they have to put their kids to bed, because there's something they want to watch something on TV, because there's just more things to do and that they're cramming into their life. Or some people even stay up that late to exercise, which is actually problematic. So we think about some studies that have been done, that were done in both adults and in college students. We see some major shifts in the amount of sleep that individuals have been getting. So in general, over 40% of adults have sleep complaints. And these can be a variety of different sleep complaints. They say, I have a really hard time falling asleep. I wake up in the middle of the night. I wake up and I can't fall back to sleep. My partner complains that I snore all the time. I feel really fidgety. Or I wake up in the morning and I'm still exhausted. And so the most common sleep complaints are actually feeling unrested or feeling sleepy, and the other is difficulty falling asleep. In 1978, 24% of college students complained of some sort of a sleep problem, and that grew astronomically, and into 2000, 71% of college students were complaining of some sort of sleep problem. So some other things that we know about sleep problems, that in 1980, college students were reporting getting about 7 to 7.5 hours of sleep. In 2002, it was down to 6 to 6.9 hours. That's a whopping difference from the expected or the ideal 9 to 9.5 hours of sleep that they should be getting a night. So it's getting worse. In college students particularly, going to bed later is definitely associated with this decrease in sleep times. And typically the bedtime is about 1 to 2 hours later than it was 25 years ago. College students nap. You could even see it probably walking through the hallways that they'll be sleeping off in the corners, right, in any time of opportunities or break. 30 to 50% of college students nap. About 30% of naps are longer than almost 2 hours, 1.7 hours. Most of them occur in the very late afternoon. When people nap, they often have a delayed bedtime, so they're going to bed about an hour later. And then as well, the total amount of sleep that they get is about 1 hour less than those that don't nap. And if we were to think about the patterns of college students, we find that most of them are phase delayed, meaning they in fact are staying up later and then they want to sleep in longer every morning. You can actually have a diagnosis of a phase delay sleep problem. It's a clinical diagnosis. And this is when you've tried to modify your sleep and you've gone through all of the nice, good sleep hygiene rules, and I'll review those later, and you still can't correct the issue of having a phase delay. But in general, most adolescents would meet criteria of being phase delayed. So how do we start to understand or think about this idea of the relationship between a population level shift in weight and a population decrease in sleep, and thinking why would we think that maybe they would be associated? Well, the first thing we can do are just do some cross-sectional studies. So this is the idea that we're just taking a snapshot in time of what's going on. Can we, if we just do a quick survey of lots of different people, say that those that are sleeping less weigh more than those are sleeping more? Okay, so this is a cross-sectional survey. And so we in fact do find this idea of a dose-response relationship between shorter sleep duration and greater likelihood of being overweight and obese. So I'll explain this diagram in 1 second. Let me just continue. Not only is overweight and obese a problem, central adiposity is also a problem. And where you carry your weight is associated with different types of risk for different diseases. And you really want to be a pair and carry your weight in your thighs and your hips and your bottom rather than in your waist. Waist or central adiposity is more problematic and more associated with disease. And so individuals that are shorter sleep duration, not only are they at greater risk for being overweight and obese, they also are at greater risk for having central adiposity. And not only is it the problem with duration, so how long you sleep, the issue is also with your quality or having actual problems. So if you're saying that, yes, I'm getting 9 hours of sleep a night, but I feel really fidgety, I'm waking up and going back to sleep, and waking up, going back to sleep all throughout the night, and I would say that my quality on a scale of 0 to 10 is not that great, 4 or 5, that in and of itself is also associated with obesity. So there were a series of cross-sectional studies that were done, snapshots in time, and what this shows is the odds of being overweight with shorter sleep. And so for every line that I have here, each line is a separate study. And what it shows here is the odds of being overweight versus the odds of being not obese, or we don't really say normal weight, but the idea of not being overweight or obese. And so the line is the idea of the confidence interval, and the bar here is sort of the average. And depending on how many people you have in your sample, you have a bigger confidence interval or not. So the amount of sort of error we have in that study. And so what we find is that here we have a series of studies that occurred from 1992 to 2007, all of which were just these cross-sectional snapshot surveys. And if you take sort of the average across all of these studies, you find that the odds are 1.89, so almost 2% greater odds of being overweight or obese if you sleep less than if you sleep more. So all of these studies are finding fairly consistent things. Here's the idea of 1. So this is the idea that no matter whether you sleep more or less, what your odds are of being overweight or not overweight would be almost the same. And so this is clearly above that. And so we would consider this to be what we call a statistically significant effect. That together, all of these studies are clearly showing some kind of an association. So somebody comes and says, yeah, but it's a cross-sectional study. You don't know what else might be going on. Maybe there's something else going on with all these individuals. Okay, we buy it. So then we start to think about we need to have more conclusive or more strength to our scientific argument. As then we look at prospective or longitudinal studies. These start to give more credibility to the case being made that there's a link between sleep and obesity. So this is the idea of, can I show not just a snapshot, but can I look at individuals and then follow them over time, looking at their trajectory to look at their risk for developing obesity. And so there are a number of studies that have been demonstrated to show this exact relationship. So if we think about toddlers, age 3, that have short sleep duration, so this is less than 10.5 hours. Remember that the toddlers are supposed to have about 12 hours of sleep a night. When they turn age 7, they have higher rates of obesity. This isn't just overweight, it's obesity itself. Shorter sleep duration, even if I take into account napping at age 3 to 5, also predicts your likelihood or your risk of being overweight at age 9 years, the idea of your overweight status. So here we have 3 to 5 years predicting age 9 years. If you report sleep problems, So this isn't just the idea of how long you're sleeping, but that quality of your sleep at age 2 to 4. It actually predicts your obesity status and your BMI, your body mass index, at 21 years of age. So this is a pretty long-term prospective study that's impressively showing a link between how much sleep you're getting young and then what that turns into later on. And these findings are really consistent. There was a meta-analysis, the idea of a big study of many other little studies that shows this is consistently found from researcher to researcher, from experimental lab to experimental lab. So many people are finding the same effect. So together, these cross-sectional studies and these prospective longitudinal studies are starting to give quite a bit of credibility to the link between obesity and sleep. So then we can go and look specifically at experimental sleep restriction. It's really hard to tell people that from now on you're only going to get 6 hours of sleep a night and I'm going to follow you for 20 years and we're going to see if you develop obesity, right? That's really not something we can do as scientists. But this is probably the next best thing to trying to make a causal association. So this is, again, work that's done by Eve von Cotter, the one that was doing the sleep restriction studies before, but now she's looking at it specifically in terms of physiology that's associated with risk for obesity. So if we look at the differences that occur in a number of different appetite regulation hormones, we see that your leptin decreases, so now you have a bigger appetite, that your ghrelin, sort of what would turn off your appetite, is even higher. You're reporting more hunger, your appetite is higher, you have a specific high appetite for high carbohydrate foods, and you're also hungry for other types of foods. So just in general, your appetite is high, but it's this idea that, interestingly, you're really hungry for these carbohydrates and salts. So if you decrease from 8 hours of sleep to 5 hours of sleep, your body mass index increases 3.6%, which is a pretty big deal. Your leptin decreases 15.5%, and your ghrelin increases 14.9%. So this is some really nice experimental evidence starting to demonstrate a potential causal association between shorter sleep duration and greater risk for obesity. Another possibility in terms of your experimental sleep reduction is the effects on the sleep response, the stress response system. And before I showed you a little bit about that heart rate when the monkey is being chased by the jaguar, here we know that you have decreased heart rate variability, so it's decreasing. You have increased, big fancy word, sympathovagal balance. So the idea is that your sympathetic nervous system is overactivated, so you're on edge. Your heart rate in general is just higher all the time. And lower parasympathetic activity, so all the things that your parasympathetic nervous system that calms your body down during rest is not happening. You also have increased cortisol levels. That's that idea of your stress response system. It's the stress hormone, and that's actually elevated the night after you were sleep deprived. And so that is going to impact how well you sleep the next night. And we also find that your glucose homeostasis is dysregulated. So how well your body is metabolizing sugars and fats starts to change. So basically it starts to look like you actually have glucose intolerance. And perhaps you've heard of metabolic syndrome at this point. Your body actually starts to mimic a condition of almost metabolic syndrome, that you have slower glucose clearance, you have a lower insulin response to glucose, you have a lower disposition index, which is essentially a risk factor or a marker for your diabetes risk, and you have lower sensitivity to insulin. So scientists have come together to start thinking about a lot of different models as to how this could be. What would be the actual causal pathways that would be linking shorter sleep duration and obesity? And I'm just going to show you just a couple of them. One idea is that, yeah, maybe all these things are going on with those appetitive hormones, but at the end of the day, you're just sitting around eating a lot more food, or you're reducing your energy expenditure because you're exhausted. Other ideas start to really tap into the difference between acute sleep deprivation, so this is the people that only are sleep deprived during exam period, versus chronic sleep deprivation. So these are the individuals that are chronically working, overworking, they can't get enough into their schedule, there's always more to do, and they're just not sleeping enough. And there's ideas that these actually may be different pathways that are affecting your risk for obesity. There's also this idea of your sleep disordered breathing. You've probably heard of sleep apnea. And there's many ideas about why sleep apnea may be associated with obesity. And there's a difference of opinion in terms of what the direction is, in terms of does obesity come first or does sleep apnea come first? And that's definitely not resolved in the literature at this point. But you really have this accumulating state of sleep debt. As this sort of speaks to the question that you asked is, can you catch up on the weekends? And you can't. catching up on the weekends. They used to believe that, oh, if you go several nights without sleeping and you get one night of good sleep, it cancels that out. That is really no longer believed. It's considered to be really a debunked myth, and that they really find that you can actually accumulate sleep debt over periods of time, that one night does not make up for it. And there's some researchers that are actually quite extreme that basically say it's sleep you'll never get back, you'll never make up for it. Another possibility of the sleep deprivation is that it's changing how our fats are stored, which could be a possibility. Individuals that are looking specifically at a stress response mechanism are also thinking about the function of cytokines and how that's associated with some of the different mechanisms in your body. And in a really simple explanation, it's probably a combination of all three of these that are linking sleep deprivation to risk of overweight and obesity. So I'm going to tell you very quickly about a project that we've started at Concordia called the Healthy Heart Project. And it's a longitudinal prospective study, so we're following these individuals over time. And what I'm just going to tell you about quickly today is youth that were about 100 youth, aged 10 to 15 years, and they came from English-speaking Montreal here in the NDG area. On average, they were about 13 years old, about half of them female, and for the most part, they were considered of normal weight. And what's really interesting is of the 100 individuals that we have a really nice, what we consider to be a distribution of their overweight status that looks just like we would get at the level of the population. And so what we did for these kids is we measured their sleep. So we actually used a PSG that they wore home for one school night. We asked them to keep track of their stress hormone, cortisol, or the endocrine functioning. We looked at their heart rate variability from a monitor that they were wearing for their PSG, and they actually wore, looks like a little Palm Pilot around for 24 hours. We looked at a few different biological markers in terms of their cholesterol functioning. We asked them to keep track of their stress levels, and we asked them about their socioeconomic status, both their perceived and their actual objective SES. And so we think about this model here, what we were first doing was looking just specifically at the links between sleep duration and overweight obesity. So just sort of this blue line without worrying about the mechanism at first. And so we found, consistent with what many other researchers have found, is that the heavier youth had shorter sleep duration and longer sleep latency, meaning they got into bed and it took them a longer time to fall asleep than the kids that were not heavier, lighter. Heavier youth also spent more time in their REM sleep and less time in their slow wave sleep or the non-REM sleep. And this is probably similar to those that have the sleep debt that I talked about before, that people that are sleep deprived when they're sleeping, more of the time is actually spent in REM sleep. Heavier youth reported more sleepiness during the daytime, more sleep problems, and they reported that their sleep quality was poorer than those that were of normal weight. And we can look at the idea of a correlation, and so that's the amount of association there is between two different variables or two different constructs, and it ranges essentially from a -1 to a +1. But what you want to think about is as this gets higher and closer to 1, the more it shows that there's a relationship between these two things. And a correlation of 0.2 is considered a pretty big deal right now in this area in science. So how big the individual's waist circumference was, that idea that central adiposity was associated with it, that the greater your sleep duration, the longer you slept, the smaller your waist circumference. If your sleep latency was greater, you actually had a greater waist circumference, meaning it took you longer time to fall asleep in bed at night, you had a bigger waist. If you spent more time in REM sleep, you also had a bigger waist. And if you spend more time in non-REM sleep, you had a smaller waist. Okay, so a negative correlation. So these are all consistent with what people have been finding previously. We then started to think about whether or not this association may be linked to activation of the stress response system. And to make a long story short, we actually found that by adding the stress response system into the model, we actually were better able to predict this relationship. So there is definitely something going on that the heavier kids also have more stress hormone floating around their body, and that in turn was associated with greater risk of obesity. And then lastly, we sort of looked at the beginning of this relationship here, because one idea is that we do know that individuals that are poorer have greater rates of obesity. We've actually done recent work to show that people that are poorer aren't sleeping as much. And so we started to look at this idea of looking at what we call your subjective SES. So we don't just want to know what your income and your education and your occupation level are, or what your parents are, but we ask you on we draw a little ladder out for them, and we say, where do you think you fall compared to other people in your community in terms of your socioeconomic status, your standing in society? Is it really high? You think you're doing pretty well compared to your community and your neighbors, or pretty low? And we have kids that will endorse any rung of that ladder. Every rung has been endorsed. And so this is the idea of your subjective SES. And what's really interesting is it's actually probably better off to perceive you're the wealthiest person in the poor neighborhood than to perceive you're the least wealthy person in the rich neighborhood, which is an interesting finding for another day. So for your sleep duration, if you perceive that you had a higher socioeconomic status, you actually were able to sleep more, you thought that your sleep quality was better, and in fact you reported less daytime sleepiness. So there's some indicators here that there's something going on at a societal level that's contributing to sleep duration. So in the future, we're going to sort of take this cohort study and follow them further, and we're going to start looking at their appetitive hormones like leptin to see if that may be playing a role, as well as their blood insulin levels. And we'll compare these kids from the community to another study that we're doing that has kids that are actually at risk for obesity because one of their parents are obese. So in general, we know that there's pretty strong evidence suggesting some kind of a causal relationship between sleep and obesity, that there's some evidence for different pathogenic pathways or causal mechanisms by which sleep might be associated with obesity. And if we look at the sleep staging, it's starting to suggest that the kids are spending less time in restorative sleep. They're spending more time in REM sleep instead. And so now we're sort of starting to look at this idea of a prospective relationship, and importantly using polysomnograph to measure sleep, not just these little inventories. And we're starting to think about how we might be able to improve sleep duration and sleep quality. So that sort of brings me to the concluding part, is thinking about some tips for sleep hygiene. Okay? So what can you do? Well, first, I think one idea in this context, thinking about school scheduling, and this is what we think of as like at a population level. We know that adolescent sleep deprivation is largely driven due to societal demands, time demands being placed on them. There's lots of things about their schedules. If you ask them what they did all day, they had tests, they had classes, and they had different things they're a part of. They're on teams, they're in debate clubs, they're in societies. So all these things together are playing a role on the demands that are putting on them and the amount of sleep that they get. So there are a number of different schools that are starting to work to think about how they can synchronize the school schedule with essentially your body clock. And they're finding that they really want teens to be in school during their most alert hours and really able to achieve their full academic potential. And the idea of changing school start times isn't an easy thing. It's not super simple. Although when you go to college, when you go to university, you start to have a little bit more personal control over that yourself. So you can adapt it to your own individual school schedule. Interestingly, in the US, there are 2 states, Minnesota and Massachusetts, that have now in fact done some really amazing statewide changes. They've actually made the start school times for high school 1 hour later, and they've actually documented the improvements in students' academic performance. The state of Kentucky has also found that they've changed in high schools the shift of time, and they've actually found that it's reduced the amount of driving accidents of adolescents, teens, and young adults. So it's quite impressive to see these major changes occurring and taking place that are supported at the idea of a population or a public health level and having measurable outcomes. So how did that apply to you? Well, if you think about sleep hygiene, that's just a term that we use to say your good sleep habits or good sleep behaviors. Some people do take medications to help them with sleep problems, but they're really only effective in the short term. And problem with sleeping pills is that often they can create dependence, or that over time you become reliant on them and then you start to develop bad behaviors in combination with those, which really only worsens the problems of sleep. So here are 12 tips you'd want to do for thinking about improving your sleep hygiene. Go to sleep when you're sleepy. Don't go to bed if you're not tired. So don't spend too much time in bed awake, and I'm going to come back to that a little bit. Get regular sleep. And this is the idea of trying to go to bed at the same time every night and waking up at the same time. And this means both on weekends and weekdays. So that students should actually not be trying to use weekends as a catch-up. They should actually try to create a balance. We've talked before about binge drinking. Well, now the new buzz is the idea of binge sleeping that a lot of students engage in. And they think that it's really just problematic. It doesn't help in the long run. So you really want to try to establish a regular rhythm even on the weekends. Have a good sleep environment. You really should use having your bed and your bedroom quiet and comfortable, and you want to limit any distractions. Try to limit the amount of noise and light. If it's a real problem for you, use a sleep mask and earplugs, and actually keep it cool. You actually don't want to have electric blankets keeping you warm at night. You want your body temperature to drop. Avoid or limit naps. So it's best, if possible, if you can eliminate naps altogether. The idea is you want to actually be sleepy when it's time for bed. If you absolutely have to take a nap, fine. Don't take a nap longer than 1 hour, and make sure they occur before 3 o'clock in the afternoon so that you don't interfere with your bedtime. Use relaxation strategies, so things like mental relaxation, different types of breathing techniques, also different stretches can really help you calm down, start up your parasympathetic nervous system. You can sit calmly, and importantly, you should have your lights dim before going to bed. So don't be sitting in a really bright room, getting all wired up. Start to relax before you go to sleep. While you're sleeping, or while you're in bed, don't watch the clock. People do this all the time. They're constantly looking at the clock. Oh my gosh, I can't believe another hour just went by and I couldn't sleep. That actually only contributes to the problem. And essentially what's happening is you're sort of having more and more negative thoughts that you're not getting enough sleep. So they say it's better if you notice that you're someone that sees the clock at night, turn it the other way so that you can't look at it all night long. Get up and try again. If you haven't been able to fall asleep and you've been in your bed for 20 minutes, get up. Don't stay in bed and not sleep. It's better to get up and do something very boring. Don't engage in a really active kind of behavior, but go do something, go read something that's really boring. Go back to bed then when you're sleepy. So just don't stay in bed without sleeping. Keep a daytime routine. If you had a horrible night's sleep the day before, the worst thing you can do is say, oh, I'm going to take a big nap to make up for it. Or else I'm not going to go do this because I'm too tired. You actually want to keep doing all the things you would plan to do that following day rather than give them up, because all you're essentially doing is reinforcing the fact that you didn't sleep and you're contributing to the fatigue cycle. Odds are if you do avoid those activities, that night you're going to not be tired and you're going to start to have that cycle happen that you're going to interfere with your sleep. So don't avoid activities because you're tired. Don't operate heavy machinery either. And then the last 4 tips is you want to minimize alcohol, caffeine, and nicotine, particularly 4 to 6 hours before you go to sleep. Many people say, oh, no, these things help me relax, but they actually really interfere with your sleep quality. Use the bed only for sleeping. And we say sleeping and for intimacy. Don't eat, watch TV, read, don't work, don't use your laptop, don't text message. All of these things are known that you're starting to pair the bed for being more than just for a place to sleep. So you want to sort of break that apart. Exercise regularly. There's lots of good benefits of exercising, but exercising regularly does in fact help promote regular sleep, but you don't want to have strenuous activity for 4 to 6 hours before you go to sleep at night. So all the people that are cramming in trying to exercise before they go to sleep are actually disrupting their circadian rhythm. And lastly, eat right. So a healthy diet will help you sleep well, but the timing is important. So you want to avoid really heavy meals before you go to sleep. Some people say you can have maybe a glass of warm milk. It actually contains tryptophan that will help you sleep, or having a very light snack, but you don't want to be consuming a lot. You also don't want to consume a lot of fluids because they would make you stay awake at night as well. So those are all the sleep hygiene tips, and I would just conclude with thanking many people that are important in terms of this work, as well as a number of the different funding agencies that do fund the research that I do. And I will we have about 5 to 10 minutes left. Just open the floor for questions that you might have. Yeah.
I have a few friends who go home right after school, and they sleep till I think 1 in the morning or so, and then they do their homework then until the morning, and then they go to school again. Is there sort of any benefits, or on the other hand, disadvantages?
The question would be whether or not, if we think about their circadian clock, if they've just completely reset it. Right, so they may have adapted. They may have created this in their bizarre little 1 in the afternoon to 1 p.m. Right. So if that's what they're is working for them, and they're being consistent in that, and they're not reporting sleepiness during the day, in and of itself, there's nothing wrong with that. Right. They've essentially become a shift worker. But my guess is that's not what's happening. My guess is if you ask them at any given time of the day, they would say that they're exhausted. And the reason for this is because light is such a huge zeitgeber, is that for most people, even shift workers, they actually aren't doing a good job of sleeping well during the day. In order to do that, when they think about, for example, hospital staff, firemen, police officers, they really need to create an environment where they basically have shades, that they eliminate virtually all noise. They have white noise in their homes to really try to rule out so that they aren't aware that it's the daytime. So unless they're doing those sorts of things, and if you told me they're not complaining of daytime sleepiness, then in and of itself, it's not necessarily a problem. My guess is that's probably not the case.
The problem with the shift workers is also on the weekends, they're adjusting
Yep.
You're going again back to the night. So their
Yep.
whole rhythm is continuously off.
That's right.
And many of them have many health issues.
That's right. There's more and more
Shift work
evidence.
all the time.
Exactly. There's a lot of evidence to suggest there's problems with shift work. Obviously, we can't eliminate shift work due to the positions that these individuals have, but the institutions that are the best do this idea of this forward shifting, and they maintain an environment to try to make that as best as possible. So the people that, like the hospitals, if you go into in the middle of the night, should be really bright for the people that are working there, and that being sort of like their regular day. But there's lots of evidence to suggest health problems and a lot more accidents and injuries that are occurring for shift workers compared to workers that have quote unquote regular schedules. There's also some interesting work thinking about who chooses shift work. And that creates a bit of an issue because odds are if people have a choice, they don't choose shift work. And so if you think back to the example that I gave of the socioeconomic status, that typically people that are of lower socioeconomic status are the ones that, it's not like they're choosing the shift work, like that's when the job is. And so that's when they go and do it. And so there's some interesting work starting to think about how that may be related as well. The work that we did with kids, here is recently we've also done some work looking at the neighborhoods that the kids live in, and that kids that live in poorer neighborhoods also have shorter sleep, and that's likely due to noise pollution. And so there's some interesting new work that's coming out sort of looking at that we can actually match the amount of noise pollution based on your postal code and the amount of violence that occurs in your neighborhood based on crimes, and how that's linked to the amount of time kids are spending sleeping. Yeah.
So do we actually need to change school schedules? Like, does that have much to do with sleep? Is it better to encourage people to go to bed early? Or does it just make sense to say, nobody can start classes at 8 o'clock, we need to start later?
It depends. There is a movement suggesting that for high schools, it's probably not a bad idea if we could, in fact, shift school schedules. But that's a huge undertaking, right? But the idea that kids should be getting about 9.5 hours of sleep, if you look at the average the school start time, it suggests that most adolescents should be going to bed around 9, 10 in the evening, and most aren't going then. And so now we can either have a policy that we change the school times, or we can try to implement telling all parents to get their kids to go to bed earlier. It actually might be easier to change school start times. What's particularly the issue is as you think about the developmental needs, that as you get older, you actually are okay with a little bit of less sleep. So that's why it's particularly important for school-age children, even youth and young adults, so college students, university students. And that's where they have a little bit more control. So if in fact they are phase delayed, which most are, it might not necessarily be a problem to start their classes. Don't take the 8 a.m., 9 a.m. class. Take the 9:30, 10 a.m. class and accommodate the fact that you are phase delayed. And then as they get older, they can sort of shift back into their work schedule of being at work at 8 o'clock. But the problem was particularly interesting for a number of high schools that had shifted without, I don't want to say without thinking, but they just sort of made a decision due to school buses and school bus schedules to avoid traffic, that they would actually get the school buses and get the kids in school before the work commute started. And that's sort of how a lot of these states actually changed their policy when they found that created even more problems by shifting it. Instead of shifting it forward, they shifted it backwards. So instead of having school start at 8, they shifted it to having school start at 7 and 7:15. And that's when they identified a lot of problems. That's when they sort of made the shift to 8:45, 9.
Saying that elementary schools, instead of starting at 9, should be starting at 8, and the high schools, instead of starting at 8, should start at 9. That would be adapting much more to the teenagers.
That's absolutely true. That's absolutely true, yeah. And now it's just a matter of convincing policymakers to try to make that happen. But I think there's definitely more and more media attention on this sort of thing. And I think people are starting to be more cognizant of those effects. But it's quite striking the amount of differences there are. But I mean, as a parent or as the individual, if you can get yourself to go to bed earlier, the better it's going to be. If individuals start to have really severe sleep problems, so they've been trying all these sleep hygiene habits, they're really just not working, they feel like they've done all these things, then they would probably want to go to a professional to start to seek out more help. And there are actually some really, really quite effective very short-term therapies that are used for people that suffer from chronic insomnia. And some of it's a little bit counterintuitive. Basically, they really start to force how much you're allowed to sleep, so that therefore the only thing you can be doing in that bed is sleeping because you are so exhausted. And then they slowly start to lengthen that out until you're sleeping to the proper amount. But it's a sleep restriction protocol that works quite effectively. Within a matter of 2 to 3 weeks, 4 weeks, you essentially have it all under control. So I noticed it, that now you can be like at 5 o'clock, like it's actually still light out, like it's unbelievable, right? And they actually find that for like societies that have these changes in the shifts of the daytime light, it's actually the idea of you can actually get they're called light boxes, that you shine on yourself to help keep your clock sort of in correct phase or correct sync. So you actually can expose yourself purposely to a number of lux, or the intensity of the light, to make sure that you stay awake. What you want to just be careful is that when it's time to go to sleep, or those couple of hours before you're going to sleep, that you're not in front of intense lights. And there's some very early work coming out looking at the people that sit in their beds at night in the dark, but have their laptop with them. And they're looking at the lux that's coming out of the computer screens and wondering if that's contributing to a lot of the increases in insomnia rates that we're starting to see. That you're actually exposing yourself to too much light when there should be a lot more darkness, and it's essentially triggering your pathway and triggering your clock. So you just want to be careful what you're doing in terms of where you're being exposed to light and how much light you're being exposed to in relation to when you're trying to sleep. Does that sort of get at what you're asking?
So it doesn't depend on like sort of like what type of light bulb it's like the energy saving light bulbs aren't gonna.
I have seen zero, like nothing changing that, because that's not how they measure the light that you're getting in. So they're not looking at the different rays or wavelengths of light. They're simply looking at it in terms of this idea of lux, or the intensity of the light. So it doesn't matter if it's a energy saving light bulb or a regular light bulb. It's more about essentially the wattage, or how bright the light bulb is. Okay, well, thank you very much.
Thank you.
Thank you.